ಸರ್ ನಮಸ್ಕಾರ.
ನಮಸ್ಕಾರ.
ನಾನು ಆಗ್ಲೇ ಬಂದೆ, ಇರ್ಲಿ.
ಹೌದಾ, ಒಳ್ಳೇದು. ಎಷ್ಟು ಜನ ಬಂದಿದ್ದಾರೆ?
ಹಾಕಿದ್ದೀನಿ ನೋಡಿ, KSCST ಇದು ಬ್ಯಾಕ್ಗ್ರೌಂಡ್.
ವೆರಿ ಗುಡ್. ಬಲ ಇಲ್ಲ,
ಪರವಾಗಿಲ್ವಾ? ಚೆನ್ನಾಗ್ ಬರುತ್ತಾ?
ಚೆನ್ನಾಗ್ ಬರುತ್ತೆ.
ಹಾ, ಅಲ್ಲ ಏನೋ ಇದು ಮೊಬೈಲ್ ಅಲ್ಲಿ ಮಾಡಿದೀರಾ ನೀವು ಲಾಗಿನ್?
ಜಸ್ಟ್ ಸುಮ್ಮನೆ ಈಗ.
ಹಾ, ಹಂಗಾರೆ ಅದೇ ವೋಟರ್ ಐಡಿ ಬರ್ತಾ ಇದೆ ಅದಕ್ಕೆ.
ಊಟ ಆಯ್ತು, ಊಟ ಮಾಡ್ಕೊಂಡು ಬಂದೆ.
ಸರಿ.
ಹೋಯ್ತು.
Yes, sir, I'm audible, sir.
To me, yes, correct.
Yeah, you are audible. Thank you.
ಎಲ್ಲರಿಗೂ ಶುಭ ಮಧ್ಯಾಹ್ನ. ಕರ್ನಾಟಕ ರಾಜ್ಯ ಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಮಂಡಳಿಯ ಸುವರ್ಣ ಮಹೋತ್ಸವ ವರ್ಷಾಚರಣೆಯ ಮಾರ್ಚ್ ತಿಂಗಳ ವಿಶೇಷ ವೆಬಿನಾರ್ ಸರಣಿ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ತಮಗೆಲ್ಲರಿಗೂ ಆದರದ ಸ್ವಾಗತ ಸುಸ್ವಾಗತ. ವೆರಿ ಗುಡ್ ಆಫ್ಟರ್ನೂನ್ ಟು ಒನ್ ಅಂಡ್ ಆಲ್ ರೆಸ್ಪೆಕ್ಟೆಡ್ ಸ್ಪೀಕರ್ಸ್, ಡಿಸ್ಟಿಂಗ್ವಿಶ್ಡ್ guests, officials from KSCST, officials from state and central government, officials from various science and technology councils across the country, principals, faculty members, students from various universities across the states, and all other participants. It's my privilege to welcome you all to the Karnataka State Council for Science and Technology's Golden Jubilee Year celebration through a year-long webinar series program. Recently, we have successfully conducted 2 webinar programs on science, technology, and innovation ecosystems and application of nanotechnology and materials engineering during January and February. Today, we are gathered here, virtually gathered here to celebrate World Water Day celebration 2025 by celebrating, organizing a webinar program on water technologies topic. Today, we have a lineup of speakers from Indian Institute of Science, ISRO, IIT Madras, Central Groundwater Board, Government of India, Hyderabad. We are deeply honored by your presence and thank you very much for joining us today with us. To begin with, now I would like to invite Dr. U.T. Vijay, Executive Secretary, KSCST, deliver his opening remarks, welcome address, and overview of the program. Over to you, sir.
Thank you, Mr. Nagaraj. Yeah, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good afternoon to all of you. On the occasion of World Water Day 2025, I wish a very happy World Water Day 2025. Respected dignitaries, for today's webinar being organized by KSCST to commemorate the celebration of World Water Day 2025 as part of Golden Jubilee Webinar Series of KSCST, Professor Praveen Ramurthy, Professor of Materials Engineering Department and Chairman, Interdisciplinary Center for Water Resources in Institute of Science, Professor L. Ilango, Professor, Department of Civil Engineering, IIT Madras, Chennai, Dr. Srinivas Vittala, Scientist, Central Groundwater Board, Hyderabad, Dr. C.J. Jagadish, Former Scientist, Digital Remote Sensing Service Center, RRSC, ISRO, professors from various engineering colleges, science colleges, universities, scientific officers from various SNT organizations across the state and across the country, here colleagues from KSCST and colleagues from different district environment centers of KSCST from various districts of the state, and here students and across the state as well as across the country. I extend warm welcome to all of you to this webinar being organized by KSCST as part of celebration of Golden Jubilee Webinar Series started by KSCST from January 2025, being organized till December 2025. This webinar is third webinar meant for water technology, different water technologies, to commemorate the celebration of World Water Day 2025. In this occasion, for this today's webinar on water technologies, I extend warm welcome to Professor Praveen Ramurthy, Professor of Materials Engineering and Chairman of Interdisciplinary Center for Water Resources, Indian Institute of Science, Professor L. Lakshmanan, Department of Civil Engineering, IIT Madras, Chennai. Dr. Srinivasa Vittala, scientist from CGWB Hyderabad. Dr. CJ Jagdish, former scientist, RRSC, ISRO. Welcome all of you to this webinar, and I thank all of you for accepting our invitation to be part of this today's webinar. I also extend warm welcome to all scientific officials, non-scientific officials, heads of different colleges, universities, heads of different state councils across the country, and my colleagues from KSCST and my colleagues from different district energy centers across the state. And last but not the least, my dear students who have joined from various engineering as well as science fraternity from various colleges of the state as well as various colleges across the country. As this today, March 22nd, being celebrated as World Water Day since 1993, the resolution, as per the resolution passed by UNO in 1992, by celebrating World Water Day by giving different themes every year. Today's theme is preserving glaciers, as glaciers is one of the important source for water. In order to preserve glaciers, the UNO has given theme for today's World Water Day, which is being organized as an important and precious natural resource, water. So KSCST is organizing this webinar on different measures and technologies on water sector. So as KSCST is also celebrating its Golden Jubilee year 2025, as it was started in 1975 and located at University of Science and registered as an autonomous organization of Department of Science and Technology, Government of Karnataka. Honorable CM of the state is the President of Council, and Honorable Minister of Science and Technology, Government of Karnataka, will be the Vice President of Karnataka State Council for Science and Technology. And the Director of Indian Institute of Science is the Chairman of Executive Committee, which is having 14 members representing different R&D organizations and different departments of Government of Karnataka, and the Chief Secretary of Government of Karnataka will be the co-chairman of Executive Committee of KSCST. As we all know that the main objective is to council is to advise the government on contemporary and futuristic problems faced by the society and suggest science and technology solutions. Just the local specific problems using science and technology and innovation, especially in the area of water conservation, energy, promotion of alternative energy sources and renewable energy sources, management of environment, agriculture, education, housing, utilization of geospatial techniques for various planning, and promoting different forms of intellectual property rights in order to foster innovation across the state for overall sustainable development of the state. So far in the last 50 years, because of its outstanding contribution to the society, KSCST has received 3 national awards for outstanding performance, national and international award in the area of energy conservation, geospatial technology, and special citation award for promoting different forms of intellectual property rights in the state. Yeah, as I told you, as part of giving solution to address the local specific problems, KSCST has been supporting various line departments of the state for overall development of the state, especially under the area of geospatial technology. We have established different district NRDMS or different district GIS centers across the state in order to provide analyzed information using geospatial technology, immersive technology, and GPS technology for district level planning. As part of developing 3D model and digital documentation of archaeology in the state, KSCST has documented digitally the 3D information on different monuments and antiquities displayed in the various government museums in the state. And water, as part of measures for water conservation, we are promoting rainwater harvesting and groundwater recharging measures in order to address both the quality and quantity. We have been supporting watershed development activities in the state, and we are trying to address the both quality and quality issues of drinking water, and especially in the area of addressing the renewable measures for traditional water harvest systems. KSCST has done scientific study on various traditional water bodies in order to suggest various measures for its rejuvenation. As part of educational sector, KSCST has been supporting innovative ideas of students from engineering as well as science team to encourage their innovative ideas as part of their project preparation as part of their curriculum. And we are establishing virtual classrooms for the benefit of our rural students in the remote areas of the schools. In order to empower teachers in the area of science and mathematics, in the area of STEM, we have been conducting a lot of programs for teachers empowerment program, and we are also carrying out a lot of science related outreach programs for overall development of the scientific temperament in among the students and teachers. We are conducting a lot of across the state, and in the area of housing, we have been promoting alternative building and green technologies with the help of IISc. And as part of energy sector, we have been promoting all renewable energy resources like wind energy, biomass, solar, green hydrogen, and biofuel, bioenergy, etc. And in order to promote non-timber forest products to improve the livelihood of tribal communities, we are promoting non-timber products in the tribal area. As part of encouraging the contribution of scientists and engineers on behalf of Government of Karnataka, we have been giving away the awards in the name of stalwarts, 14 awards being given to outstanding performance of scientific engineers every year on behalf of Government of Karnataka. There's Science and Technology Awards, and especially in order to support innovation and invention in the state R&D, we have been creating awareness programs and handholding registering of various patents, copyrights, and trademarks as part of different IP parks of intellectual property rights among all R&D institutions, startups, and academic institutions in the state. Coming to water, as I told you, as part of promoting various measures for water conservation, KSCST has been promoting rainwater harvesting and groundwater recharge, different types of different measures of rainwater harvesting, groundwater recharging by creating awareness, by conducting various training programs for engineers, architects, and plumbing contractors across Bengaluru city as well as across the state to take up rainwater harvesting and groundwater recharging scientifically. We have been supporting technically by giving detailed project reports containing designs, estimation of different components of rainwater harvesting to various government institutions. So far, more than 600 such government and non-government institutions have been supported technically by KSCST as part of rainwater harvesting promotion. And KSCST has developed a do-it-yourself RWS tool app for rainwater harvesting. And KSCST has been conducting various awareness programs, live radio and TV programs in order to create awareness on rainwater harvesting and groundwater recharging, and especially as a unique measure to demonstrate various methods of rainwater harvesting and groundwater recharging in association with Bengaluru Water Supply and Sewerage Board. KSCST has established first of its kind rainwater harvesting theme park in Jayanagara 40th Cross in association with BWSSP, wherein 27 different methods of rainwater harvesting and groundwater recharge models have been displayed for the demo among various general public, NGOs, students across the state and across the country. The first of its kind in the country itself. And we conducted more than 300 awareness programs and more than 300 demo and exhibition to promote rainwater harvesting in the state. Next slide. So, including Vidhana Saudha, High Court, Lal Bagh, Kabban Park, many government organizations, government offices, universities, hostel buildings, hospitals, court buildings, and many other organizations have been supported by KSST as part of promoting rainwater harvesting. And conducted more than 700 quiz programs, lectures, seminars across the state for the benefit of our students. And with the help of KSCST, help desk being established by KSCST in RWS theme park at Jayanagar as well as KSCST, around 1,95,000 housing properties in the Bangalore are able to install rainwater harvesting in their domestic premises as part of rainwater harvesting and rainwater recharging. And we have conducted 95 training programs for engineers, architects, and plumbing contractors of both BWSSP and BBMP to guide and to install rainwater harvesting in their areas. And their details have been displayed in our websites, both in KSST as well as BWSSP website. Next slide. Yeah. And also, as I told you, in order to rejuvenate traditional water bodies in the form of Pushkarani or Kalyani, Kunte, Gokatte, Katte, which were constructed by our ancestors to hold water for various uses, including groundwater, KSST is able to identify such traditional water bodies across the state by visiting each and every Grama Panchayat of the state, by locating these structures using GPS as well as geospatial technology. We have assessed their hydrological and physical status and given scientific measures for these rejuvenation of these water bodies to the respective DC, Jilla Panchayat CEO and RDP department in particular in the state. All these water bodies have been taken up under various schemes of both Government of Karnataka and Government of India for the rejuvenation. You can see 2 or 3 photos how the structure was before our study and after the rejuvenation, how it looks like. So this is the impact of assessment of traditional water harvesting system and measures for rejuvenation. The study conducted by KSST, it has been given to the respective Jilla Panchayat and respective DCs of the state. So supporting the state government in taking up this restoration work of surface water bodies under various state and central support schemes, this report has helped them to rejuvenate these water bodies. So this is the list we have given and the map which is showing the exact location of these 14,000 odd traditional water bodies, showing the geographic location, and also this table showing the number of water bodies, number of water bodies in the respective district and its quantity also. Next slide. As part of addressing the quality issue also, drinking water issue also, KSST has established different defluoridation units in part of Kolar as well as Tumkur district. And in order to address arsenic, one of the dangerous component found in 2 districts, there is Yadagiri and Rajasthan district, we have used the technology developed by IIT Madras Professor Pradeep from Chemical Engineering Department. We have established 2,000 liter capacity using nanotechnology based filtration system in Yadagiri district and 5,000 liters capacity in Rajasthan district, that is in Medinapur. Using this water, treated water, arsenic free water being used by the residents of those 2 villages, and this has helped to improve their health status also. With this, KSST has been promoting various measures for water conservation which will be useful for future generation. With this introductory remark, I invite and request Professor Praveen Ramurthy to formally inaugurate and deliver inaugural address. Over to Professor Praveen Ramurthy. Sir, over to you, sir.
ಥ್ಯಾಂಕ್ ಯು ಡಾಕ್ಟರ್ ವಿಜಯ್. ಎಲ್ಲರಿಗೂ ಸುಸ್ವಾಗತ ವಿಶ್ವ ಜಲ ದಿನದಿಂದು. Esteemed guests, respected colleagues and friends, it's with great honor and pride that we gather here today to celebrate a remarkable milestone, the Golden Jubilee of the Karnataka State Council for Science and Technology, KSCST. For the past 50 years, KSCST has been at the forefront of driving scientific and technological advancements in Karnataka, serving as a beacon of innovation and progress. Since its establishment in 1975, KSCST has played a pivotal role in fostering research, supporting grassroots innovations, and enabling the application of science and technology for the welfare of our society. As a part of this momentous occasion, KSCST has organized, as Dr. Vijay mentioned, a year-long series of Golden Jubilee webinars and scientific activities. These initiatives are designed to engage diverse stakeholders, promote knowledge sharing, and contribute to the overall development of our state. Through these engagements, KSCST continues to strengthening the science, technology, and innovation ecosystem, right? The STI, addressing the contemporary challenges and creating sustainable solutions. Water quality measurement is one such critical area that exemplifies the importance of science and technology. Ensuring clean and safe water is fundamental to public health, agriculture, and industry. The study of water quality has evolved into an interdisciplinary field, incorporating expertise from environmental science, chemistry, engineering, data analytics, and many more. Precise water quality assessment helps us monitor pollution levels, protect ecosystems, and develop sustainable water management policies. This interdisciplinary nature of water research finds synergy in the collaboration between KSCST and the Interdisciplinary Center for Water Research, ICVAR at IISc. ICVAR, with cutting-edge research in hydrology, climate resilience, water resource management, complements KSCST's mission to apply scientific knowledge for societal benefit. Together, these organizations exemplify how interdisciplinary collaborations can drive impactful solutions in water conservation and management. Furthermore, as we observe World Water Day, this is a crucial moment to reflect on significance of water sustainability and the urgent need for scientific intervention to ensure water security for future generations. World Water Day reminds us of our collective responsibility to efficiently protect and manage our water resources. It underscores the importance of interdisciplinary research and policy making in addressing water-related challenges, reinforcing the vital role that institutions like KSCST, ICVAR, and many others who are on this panel in this endeavor. I want to take this opportunity to extend my heartfelt gratitude to Professor Ashok Raichur, Secretary, and Dr. UT Vijay, Executive Secretary, and all other members of the KSCST for giving me the privilege to speak on this special occasion. Their leadership and dedication have been instrumental in taking KSCST to newer heights, and I wholeheartedly congratulate them for their remarkable efforts in advancing science and technology for the benefit of society. As we embark on this Golden Jubilee celebrations, let us acknowledge the achievement of KSCST and reaffirm our commitment to advancing science and technology for the betterment of society. Let this occasion serve as a reminder of the power of collaboration and innovation in shaping the sustainable future. Thank you. Jai Hind and Jai Karnataka.
Thank you, sir. Thank you for your valuable inaugural address, which is very inspiring. And now I request and invite Professor Lakshmanan Ilango to share his research measures on water conservation. Over to Professor Ilango from Department of Civil Engineering, IIT Madras, Chennai. Professor Ilango. Professor Lakshman Ilango.
He is online.
He is online. I will call him.
Hope you can.
Yeah. Yes, sir.
Thank you. Thank you.
Thank you, Professor Roland. Yeah, you could show the presentation.
Yes. Can you see the slide?
Yes, sir.
Now,
Yes.
Very good afternoon to all of you. It's a privilege to speak to the learned colleagues as well as friends who are attending this event to celebrate World Water Day. I thought of sharing some of our experience on sustainably managing the groundwater resources. All of us are well aware that we are at the midst of a storm, especially considering the fact that the atmospheric temperature is rising at an alarming rate. As you can see in this diagram brought out by IPCC, right, they had projected the climate change impact until 2100 under different scenarios. That means the one at the bottom is the most likely we won't be able to. That is the most sustainable solution, whereas the one at the top is the path which we are in currently, right? That is the topmost one. And even if you assume that we are going to take some midway, the temperature is going to rise at least by 1.5 degrees by the end of this century, in another 75 years. And considering this fact, for the country, that is for our country too, people have projected how that temperature is going to rise, right? If you look at the recent publication by this group of people, indicate that the measured temperature rise in India, right? That means these are all the observed temperature rise in India, which also indicates from 1960 until 2010, the temperature has rise at least by 0.75 degrees. Taking clue from that, people from IITM Pune has projected how the temperature is going to rise, as we had seen previously under different scenarios or using different climate models. All the models predict by the end of this century, the temperature is going to rise by 2 to 4 degrees. And what is interesting for our country is it is going to we are belonging to such a large country, the temporal variation, or more than the temporal variation, spatial variation is much more interesting, right? Considering the fact that the temperature is going to rise very much in the northern part of India, as you can see in this diagram, which means the theme of this year's World Water Day, as you would have seen in the first page, save our glaciers. Right? That means we have in India glaciers, mostly in Himalayas, they are under threat. In fact, I gave a talk on the Himalayan glaciers recently, during which I had gone through, though I had not worked on that area, I had collected a lot of information. What is alarming from this picture is you can see one of the important glacial lakes, right, in the Himalayas, which you can see at different times. The work was carried out by ISRO from 89 to 2022. You can see how the glacier size of the glacier or size of the glacial lake has increased. What does it mean? That means we are losing the ice even in Himalayas, as indicated by the previous picture where the temperature is continuously rising in India, right? That too in the northeastern part, especially in Himalayan region, as you can see in these diagrams, right? And from the observations we have made, making use of the satellite data, the size of the lakes are increasing, which means what was previously occupied by ice got melted and the lake has extended at least by 2 times. leading to water scarcity even in our in Ganges basin as well as Indus river basin, due to the fact that the ice melts and most of the water toward the sea. Keeping this on one side, how the rise in temperature or climate change is going to affect groundwater. The most important aspect by which it is going to affect groundwater resource is possibly depletion of groundwater resources. How? As the atmospheric temperature rise, the evaporation is also going to increase. If this is the ground surface, as the atmospheric temperature is rising every day, the quantum of water that is evaporating from the soil as well as from the trees and leaves and from the canopy of forests are going to increase. As the evaporation increases, during the subsequent rainfall, the recharge will also get reduced. There will be change in the way in which groundwater is recharging today and in comparison with what is going to recharge in another 25 years. Right? After 25 years, atmospheric temperature would have risen at least by 1 degree. So due to which recharge will also correspondingly get reduced, because the whatever water that falls after rainfall, first of all need to satisfy the soil moisture deficit in the upper soil zone. Only then it can go and reach the groundwater zone. Adding to this problem, we are also heavily urbanized, right? Especially large cities like Bengaluru or Bombay, Chennai, Kolkata. We are also adding to another dimension of a problem, which is urban heat island, where the temperature in the cities are much higher than the surroundings of the cities, right? At least by 1 or 2 degrees. And as we are heavily urbanizing, we are changing the land use and land cover, due to which the recharge will also get reduced, because what the paved area, there are a lot of paved area, a lot of buildings which would have been occupied previously by open surfaces, where that would have facilitated recharge. So land use, land cover changes will also reduce the recharge. The change, atmospheric temperature rise as well as climate change is also creating an impact on the water quality, both on the surface water as well as groundwater. For example, water that is stored on the surface, more evaporation will lead to rise in the concentration of solutes in the water. Right? The same water is getting recharged, so quality of groundwater gets affected. Rise in atmospheric temperature also increases the temperature of groundwater to some extent, right? This is the water table and this is groundwater. Groundwater in accordance with the way in which atmospheric temperature, due to which the way in which rock and water is interacting today will also change, right? Is especially in coastal areas, sea level is rising. Change. For example, in oceans, 2 millimeter per annum data. Even in Chennai, for past 60 years observed, tidal gauge data indicate the sea is rising at the rate of 2 to 3 mm per annum. This will cause more sea water to enter into the land. For example, this is the land side, this is the sea side. As the sea is rising, again, the seawater on the land side will also be, this would have been the intruded area, but as the sea level rises, the area occupied by the intruded zone will also increase. We face issues in groundwater, right? Especially depletion of groundwater. As the groundwater depletes, what we will do? We will start extracting more and more groundwater, right? Because most of the country is dependent on groundwater except for urban regions, right? So we will tend to take more amount of groundwater. What is the way forward? So way forward is purposeful, as rightly said by the previous person and also by the scientist who spoke initially. I was thoroughly happy with the initiative taken. That is the way forward to meet the climate change. Right? If you want to be climate resilient, we need to increase the way in which the water is getting recharged today. So that is what we call it as managed aquifer recharge, which means purposefully we want to recharge the water into the aquifers. This is a kind of nature-based solution. Naturally, also rainfall is getting recharged. We are making some minor intervention to improve the groundwater recharge. How we are intentionally replenishing the groundwater through natural process, like by facilitating infiltration. What are the ways, right? We can have some spreading ponds or injection wells, as you can see here. Also try to wastewater, and the treated wastewater can also be let into the surface water bodies, which will again maybe kind of water circularity. That is, whatever water which we use, we put it back beneath the surface of the earth. From some distance, we can pump and use the same quantum of water. So what you see here is the process followed in Egypt, where they have several contour bunds are made. That means the bunds are according to of same elevation. So several such bunds are made. So we store the water in the form of a step lakes. So if without these bunds, whatever water that has fallen would have led to runoff, eventually would have met the stream and eventually would have gone into the sea. To prevent that, this is one way of managed aquifer recharge known as spreading ponds. So what you see is a percolation well, right? A well where the local, he had also mentioned, a locally falling rainfall can be diverted to the percolation well. So the soil's percolation rate will be less in the surroundings, whereas you facilitate a fast rate of percolation through a recharge well. So these are all some of the measures which will help us to overcome the issue of climate change impacts. This is what is known as a percolation pond. So a percolation pond can be made at a number of places to store part of the rainfall, so that half of it will at least recharge the groundwater resources. I would like to quickly, I will take about 10-15 minutes more. I would like to touch upon some of the case studies on which we have worked. One is on Dugwell. I don't want to read this. Maybe I will go one by one. So there are regions within the, especially in southern India, at many locations, groundwater is very affected by fluoride. We have done studies at these sites, including some parts of Karnataka, as you can see. Right, I would like to highlight one study among this, that is at this location. We carried out a study to overcome the problem of fluoride by improving groundwater recharge. We carefully selected a site based on a long-term, 3-year long-term study. We understood the process of recharge and its impact on groundwater quality. Based on that, we selected a site where there is a large diameter well that is existing, which was naturally getting recharged through the natural filtering process. So what we did, we identified an adjacent place which is reasonably clean, where the farmers use a small area to store their food grains and staple. So such a site was identified. Whatever rain that is falling in that site was allowed to get diverted into a small well, right? It is a simple structure of about 1 meter by 1.5 meter in depth was made, and it was divided into several sub chambers, so that the local rainfall that is falling in this site will get into this drain and it will flow into the recharge well. It will pass through different chambers just to filter out the suspended sediments. The filtered water is allowed to directly fall into the well. So what is the impact of this? So such a simple structure has improved the ground. This is the site at which we made this intervention. You can see the groundwater level over there is 471. And this is with reference to mean sea level. So what I want to say is, over here, water table is much higher than 471, 470, and 469, and so on. That means this has led to suppose if I draw a cross section here, so the cross-section groundwater table will appear something like this, because this is the location at which the dugwell is located. Here we are diverting the rainfall into a dugwell system. So water table has improved. Just beneath that, the water recharge will eventually flow in all the 4 directions. What is the impact of recharge on water quality? So here you can see at the bottom is the rainfall, and in response to the rainfall, groundwater table is rising and falling. On we had after in the recharge structure or other, as we are directly diverting the rainfall into the, as more quality of water as in connectivity of groundwater, electrical connectivity directly refers to total dissolved solids groundwater, which has gone down considerably. And this is the problem for which we went ahead for this study. Fluoride groundwater is having high amount of fluoride, where the maximum permissibility is 0.5 milligram per liter, between 3.5 as the concentration. After concentration was around 1.5. So fluoride concentration decreased from 3.5 to 1.5. The total dissolved solids also has decreased, whereas water level 4 mean. Though we completed the first project by 2015, we continued the next subsequent project, and we continuously monitored for further period of 3 years. Right here you can see this is the data of our intervention. Fluoride concentration was remaining below, right? Though we did this intervention in 2014, we continued monitoring until 2017, as you can see here. So continuously, the concentration of fluoride was much below or around 1.5. So this is how we are able to intervene and overcome the problem of deterioration of groundwater quality with respect to fluoride. In the next study, as I told you previously, we did the studies nearer to Chennai over a saline aquifer, right? Because the aquifer is saline because of the geological past. The sea was once inside, due to which you have marine sediments here. So groundwater is very, very saline, almost of the quality of seawater. So what is the way forward? Can we, people are, now they are all served with the desalinated water. At the time they were suffering, so why not we going for a percolation pond? So we first constructed a percolation pond over that site, and we found out the recharge from the percolation pond is not really sufficient due to a poor sediments, poor infiltration rate in the sediments, as the sediments are mostly silty sand, sometimes sandy silt. So to overcome this problem, then after a year of studying the recharge from the percolation pond, we went ahead for a recharge shaft at the center. That means it is a kind of an inverted well with a screen at the top, so that the pond water can directly enter into the groundwater zone through the recharge well. So this is the picture showing the construction process. In the next slide, you can see how this has improved the groundwater recharge. Right, the diagram at the bottom was the first year of our observation between 2012 to 2013. Right, this is the amount of recharge from the beginning of monsoon till the end. Right, during the subsequent year, we constructed this recharge shaft. Due to that, the recharge has considerably improved to almost 2 to 2.5 times. There is an increase in groundwater recharge. Seeing the benefit of this, the people who are living in the adjacent village also went ahead for such a percolation pond. Then we have also installed a small hand pump at this side. Right, the hand pump can give about 150 liters of water per day, because the water, this is the saline groundwater zone. The fresh water which has recharged will be floating like a small lens, because it is much lighter. Right, the density is only 1, whereas the seawater is 1.025. A small lens of fresh water can be slowly withdrawn, cannot be done by a mechanized pumps. So this is how we could improve the quality of water by percolation ponds. In another large site, again north of the city of Chennai, 2 rivers. The groundwater here is very much affected by poor groundwater quality, partially due to seawater intrusion. So over there, to improve the rural water supply, check dams were constructed. So this is one of the largest check dam located at this area. This is the city of Chennai. To improve the rural water supply, can we think of a river bank filtration? So, inside of the check dam, so why not we have a well at appropriate distance to make use of natural filtering process. Suppose if you tap the directly the river water will be very much contaminated, especially microbial contamination will be much higher. If you pump groundwater from some appropriate distance, there will be natural filtration. We will be actually pumping river water, but we pump the river water that is flowing through the formation. Right? So this process is known as riverbank filtration. So we carried out a study to see whether this is feasible across the check dam. This is the direction of flow of the river. C is somewhere here. This is the check dam. So due to the river normally flows only for 40 days in a year. Due to the construction of a small check dam, water will get stored on the upstream side nearly for 3 to 4 months. So during this time, we can locate some pumping wells at appropriate distance to facilitate the natural filtration process. Right? Here, this is what I was telling you. Here you can see this is how the electrical conductivity varied. This is the water from the river, that is from the check dam. On either side, in groundwater, you can see the groundwater is of comparatively poor water quality. River water is very good chemically. That means it is only having 600 microsiemens per centimeter of electrical conductivity, which means per liter. Whereas groundwater is much more deteriorated. In contrast, if you look at the microbial content, which you see on the right-hand side, the number of microbial colonies are much, much higher in river water, as I had just now mentioned, because of the surface water mixing with the river water. That means there are a lot of activities going on. Maybe people may come and use the river water for bathing or washing, and also cattle washing and so on, leading to higher amount of microbial load in the surface water. Whereas chemical not be directly tapped for water supply. So what will be the appropriate distance at which we can locate the pumping well to facilitate natural filtration? That can be mathematically evaluated. And then we came out and said, if a pumping well is located beyond this distance from the river, that means beyond 400 meters. Suppose if there is a well, if you can tap this well for rural water supply, the water will be completely clean, because if the surface water travels through the formation nearly for 40 to 50 days, right, the water will be reasonably clean. So leading to decrease in the quantum of microbes. So this is how carried successfully get comparative from the river. The river, though it is from the river, we call it as groundwater. Right? And I had already mentioned about this. So this is the safe distance. I already mentioned to you, beyond 50 to 60 days. That depends on the hydraulic conductivity of the formation. So this is how we identified the appropriate distance. In the last study, the same area is also suffering due to seawater intrusion, right? Seawater has intruded nearly up to 15 kilometers. There is a picture I'll show you. So we carried out a long-term study at this site. So here you can see the variation in the concentration of ions at different times from 1969 to 2014. In 1969, this is the location of the sea, distance from the sea. So this is how concentration of sodium varied in groundwater. Very close to the sea, it is about 15,000. Within 3 kilometers, the concentration has drastically come down, right, in 69. Whereas in 2014, up to 14 kilometers, concentration of sodium is much, much higher, right? Much higher. So similarly, on the right-hand side, you can see the variation in the concentration of chloride, which is also much higher, right? Currently in 2015, right? Here is the variation spatially. You can see in the black color is from the year 1988, the concentration of this color, right? It is only chloride concentration is only 600, whereas in 2014 it is about 6,000. So what is the way forward? Can we go ahead for managed aquifer recharge by constructing several check dams across these rivers? 15 check dams were suggested. All of them have been completed now. And I told about the percolation pond and rejuvenation of the lakes and the possibility of linking these two rivers, which are yet to be taken up by the government. Currently, they are considering this project too, right? Suppose if you go in for all these measures, if you, as we had seen previously, if you look at the quality of water in check dam in terms of chloride, concentration be only about 120 gram per in ground continuous with respect to distance, right? Similarly, based on this, we identified by storing water here, we can approximately improve the groundwater storage over this area as well as its quality. Taking clue from this particular study, we extrapolated our results for the rest of the check dams, right? Linearly, right? Based on their size, right? We extrapolated the benefit to rest of the check dams, and then we went ahead in carrying out a large-scale numerical modeling for the entire basin, considering the presence of check dams, right? Considering the expected rainfall, what will the rainfall will lead to how much of runoff, the runoff will lead to flow in the rivers, that will lead to recharging groundwater, and we also considered the density difference in groundwater. Making use of this study, we identified if you go ahead with these interventions, the seawater has included up to this distance in 2015. If due to these interventions, our study indicated in another 5 years, there will be recovery of the quality of water, right? The seawater freshwater interface will be pushed at least by 4 kilometers in the next 4 years. So this is what I wanted to share, and toward the end, maybe I'll share some of our recent work which we are doing in Bangalore city, which may be of interest to you. This is what you had also mentioned, that in association with United Way as well as Aquamap, another center from IIT Madras, we are going ahead in constructing about 10,000 recharge wells in the city of Bangalore. I just wanted to share that, right? So this will eventually, right, by simple calculation, right, we will be able to save so much of water by going in for 10,000 recharge wells in the city of Bangalore. That is it. I'd like to conclude stating that as we had discussed, climate change has got a tremendous impact on groundwater. The way forward is to improve the recharge, which will improve the groundwater storage as well as the groundwater quality. However, a systematic study is necessary when we are talking about the quality of water. Recharge will also lead to some adverse impacts on the quality of water, hence it requires a systematic long-term study. Recharge also reduce the flooding. As I told you on the previous slide, 50,000 meter cube of water is going to be diverted into groundwater. So at that much of amount of water, we need not worry about in designing these stormwater drains. However, these recharge structures at many places in India we construct and forget, so which is of no use. Clogging is a major issue. So every season this requires cleaning. So long-term maintenance, in fact, is a challenge. Right? Similarly, the quality of water that we use it for recharge is also a concern, especially if the water comes from a heavily urbanized region or from an agricultural region. The water which is recharging may also be of poor quality, which may deteriorate the quality of groundwater too. That is it. Thank you very much for your attention.
Thank Thank you, Professor. Thank you very much for your valuable information given on status of groundwater, measures for groundwater recharging and artificial recharging, and also case studies in Bangalore city as well as Chennai also. Thank you very much once again. I take this opportunity to thank you once again. And I invite. Thank you, sir. Thank you very much.
Please excuse me. Similar function is going on here in our department. Thank you so much.
Thank you once again.
Best wishes. Thank you for the opportunity.
Thank you. If any questions are there, we'll get it from email and it will be addressed with the help of respective resource persons. Now, I invite and request Dr. Srinivasa Vittala, scientist from Central Groundwater Board, Hyderabad, to share his experience in the area of status of groundwater. Over to Dr. Srinivasa Vittala.
Yes, sir.
Dr. Srinivas? Yeah.
Yes, sir. Yes, sir.
Thank you for joining, and now over to you.
Yes, sir. Can you able to see my PPT, sir?
Yeah, able to see, but please make it full screen. Yes, yeah.
No, sir.
No. Please press F5 or
Yes,
slide
it is
show.
in full screen.
No, sir. Actually, you have to come out and then again share because it is not coming. Full screen is not appearing.
Yeah.
There should be
Slides,
some
you can press
problem.
the slide.
Please exit sharing and then share entire screen, sir. You choose entire
Okay.
screen.
Karthik, mute yourself. Karthik, mute yourself.
Rao, ನೀವೇ mute ಮಾಡಿ.
Person, please mute Karthik's. Yeah, okay. Dr. Srinivas,
Can you see now, sir?
still it is visible like that only. Now,
Sir, you have to exit presentation, again share the screen, sir, because you have to select the entire screen while sharing.
Okay.
yeah.
Yeah.
You can open and
Now?
now, yes,
Yes, sir. Perfect.
so visible. Yes, that is full screen. Please go ahead.
Thank you, sir. Good afternoon,
Yeah.
all the scientists and working community present over here. Thank you, Ganesh, sir. And once again, happy World War Day to all of you. My very congratulations to all of you. So in this brief presentation, I am going to talk about the groundwater, what is the scarcity, security, and its management for its sustainable development. And myself, Dr. S. Srinivasa Vittala, working as a scientist in the field of hydrogeology in Central Groundwater Board, Ministry of Jal Shakti, Government of India. I am located in southern region, Hyderabad. So just can you next slide, sir? Can you see, sir? Next slide.
Yes,
Yeah,
sir.
yeah.
Yes, sir.
It's visible.
Yes, sir. So here you can see the entire total groundwater available out of total 100%, the 96.5% is of oceans, and 0.9% is from the saline, and out of 100%, 2.5% is from the fresh water. Now we can imagine across the globe, only 2.5% of the fresh water is available. Next, coming to this, out of 2.5%, the nearly 69% is made up from glaciers and ice caps, and groundwater, which forms about 30% out of this 2.5% of fresh water, whereas the surface water and other fresh water is of 1.2% only. So out of this surface water, the groundwater ice and permafrost is of 69%, lakes is around 21%, and the remaining is from atmosphere, living things, rivers, swamps and marshes, and soil moistures. So you can able to imagine now what is the amount of fresh water is being available across the globe. Even in the fresh water, how much is from the glacier and ice caps, and the remaining is from the groundwater and surface water. So this is the groundwater which is accountable as a freshwater resources. About total of 97% of the groundwater available in the global is essential for human and economic development, out of which 1/3 of the world's is going towards drinking water, and 40% of these groundwater resources is going towards irrigation sector. Out of these, 25% of the world's total water goes towards the industrial water. This is how the global groundwater has segregated across different sectors. So this is the water as a global issues, where water crisis has steadily moved up in the global agenda. Nowadays, wherever the forums you visit, wherever the forums you hear the things and attend, the major discussion is of water crisis. In India or across the globe, out of the 100 sessions or seminar which happened, more than 50% of the topics are covered in water sciences. That is how the water has attracted one of the burning issue among other issues on the globe. And also, as the population increases, decreasing of per capita availability is also noticed. This is common in almost all the countries, as whether it is a fresh water or is a groundwater, the availability is same. But as the population is increased, naturally decreasing per capita is limited. As the water availability is increased and exploitation is further increased, naturally deterioration of water quality is also a common factor. That is the alarming situation nowadays in the globe. The increased competition and also conflict within the sectors, whether in urban versus agriculture, or haves versus have-nots, and upstream versus downstream, as well as national versus international. The increased competition as also with the environment is one of the global issues in water. So this is the groundwater stress. What is the scenario for 2040 across the globe? So in India and other adjacent countries, we have noticed groundwater depletion by more than 40%, whereas the rest of the countries in Russia and Southern America and also Canadian states and also part of the Central African countries, still there are some resources available. So with respect to India, it is a alarming stage where the limited availability of groundwater is there, but the exploitation is increasing over a period of time. So this is the groundwater scarcity across the globe, where India is falling extremely high exploitation category compared to other countries. So this is the per capita water availability in India with respect to world, where you can see India, it is 2200 meter cube per son per year. If you see in Russia and USA, it is most prosperous and are well, almost all developed countries are having a highly technological tools for conservation measures with respect to groundwater as well as surface water. But even in Israel also, though it is 450 meter cube per person per year, they have adopted the latest tools and technologies in water sector. You must be aware and heard of the recent technologies incorporated by Israel in groundwater conservation and also surface water conservation. And in India is very much, this is the right time and alarming time for the India to take a suitable actions for conserving the water with respect as the population is increasing. This is the slide showing per capita water availability in India with respect to world. So this slide indicates the how India is one of the biggest consumer comparing to other countries across the globe. So in India, it is more than 120% of groundwater using compared to China and US. So you can see India followed by China, USA, Pakistan, Iran, and other countries, how they are gradually reducing their groundwater consumption. And also because one of the population, though China is one of the populated country, because of their highly technological tool conservation measures, still they are limited in using the groundwater as a user. But in India, it is also very much, it is a high time to take necessary actions to arrest the groundwater conservations and also reduce the groundwater conservations. So this is the map which is indicating the assessment of groundwater resource estimation as in 2022. So this is prepared by Central Groundwater Board, Ministry of Jal Shakti, Government of India, where you can see the northern India, including Rajasthan, Haryana, Punjab, and part of Madhya Pradesh, and also in the southern states, in the Adrak terrains of in parts of Karnataka and Tamil Nadu, and also part of Andhra Pradesh and Telangana, where we have used the stage of groundwater extraction is more than 70%, that is under critical, and more than 100%, which is falling in overexploited area. It means that you have an account in 100 rupees in your account, you are using more than 100 rupees from your account, resulting over exploitations. So in the similar way, in the same way, if you are using only 25 rupees out of 100 rupees, you are in a safe zone. So this is the another indication of groundwater extractions more than the availability, resulting over exploitation. So this is the taluka wise categorization of the mandals, where you can see a clear picture where the groundwater is being exploited at large. Especially in Karnataka, we are using, though some of the districts are falling safe because of the good measurements, artificial measures, but still some of the parts are falling in critical as well as overexploited talukas. So this is the groundwater extraction stage, the view of utilization of groundwater in India. So this is the data which is showing the groundwater extraction from 1991 to 2020 and goes on. So in 1991, the stage of groundwater extraction is 32%. So it, as I told you, out of 100 rupees, we have spent only 32 rupees in the year 1991. But in 2020 and also in 2022, the figure is almost same. We are spending around 62% of groundwater and falling as the population is increasing. So groundwater extraction is also gradually increasing. So you can see the groundwater extraction scenario from 1991 to 2020 in these current scenarios in slide. So this is the groundwater usage in the agriculture sector compared to other countries across the globe. India is one of the largest groundwater use for the agriculture sector. So it has over 20 lakh irrigation, 20 million irrigation wells. Every year that number is added by 0.8 millions. So you can see in our own lands, in many of the southern part, even if I have 1 acre of land for a crop of paddy or sugarcane or banana, I am going to have at least 1 to 2 bore wells, which is yielding around 1 to 2 LPS minimum. So this is how each and every agricultural plot nowadays is having one irrigation well. So this is how every year these wells have added up, so grossing in resulting the over exploitation of the groundwater, especially for the agriculture purpose. Every fourth cultivator owns an agriculture well. As I already told you, so in a village, almost all the owners of an agriculture land, maybe more than 60% to 70% of the agriculture owners are having at least single wells, minimum of 1 well and a maximum of 3 to 4 bore wells in their agricultural land, which is depending upon their area acreage. If they are really worth, or if they're really going for a cash crop, they have minimum of 2 to 3 bore wells in a year. See, if one farmer adjacent to our neighbor is having that kind of a groundwater exploitation, see, if you imagine this figure across India, how many bore wells are being drilled for agriculture sector. See, in this graph, you can see how India is picking up in usage of groundwater, whereas in the year between 1950 to 1960, due to Green Revolution, the groundwater draft has increased drastically, along with the White Revolution in the year between 1970 to 1980. So along with the same trend is increased with respect to the groundwater usage in agriculture sector. So if you observe these curves with reference to other countries, they are well off. Even since 1940 to 2010, they are almost same, and also they have the awareness of how to use the groundwater, whether with respect to agriculture or with respect to industrial purpose or whatever it is. So this is how, because of the population growth, India is also one of the user of groundwater across the globe. And also the non-owner of the groundwater well is also dependent on groundwater. This is one of the reasons, few reasons, how India is one of the stakeholder in groundwater usage sector among the other countries in the globe. So this information indicates the water use over a period of time with respect to surface water and groundwater. So if you see a surface water trend from the year 1955 to 1999 and even till 2020, the usage of surface water is almost same. So whereas in case of groundwater, it has increased in manifold in the span of these 6 to 7 decades. So as the population is increases, as the area acreage is increases, as the cropping pattern is increased, naturally the India is completely now gradually shifting towards the usage of groundwater for their agricultural purpose. So this is one of the reason why groundwater is being exploited over a period of time in India, whereas the surface water usage remains same within this period. So this is the per capita water availability in India against the population. See, with respect to population, as the population increases, the groundwater availability decreases naturally. See, in the year approximately in 1950, the population availability of groundwater is manifold increase compared to the recent years. So in the clear, as the population increased, the groundwater availability is decreased from the period 1950 to till date. And also if you project till 2050, the trend remains same. So this is the water crisis scenario in India with respect to the global water usage. India accounts for 60% of the groundwater is used for irrigation purpose. It is one of the largest country where irrigation is the lifeline of India. So in addition to this, 85% of the rural drinking water is completely dependent on groundwater sources. So 50% of the urban water is also dependent on groundwater sources. More than 80% of the net irrigated area since last 4 to 5 decades are completely dependent on groundwaters. So this is the one of the reason why India is the world largest groundwater user among the other countries. So with respect to the concerns, India is one of the largest user of groundwater, drawing more than 250 kilometer cube per year, over 25% of the total world's water. So resulting over-exploitation of water and also deepening of water level and also exploitation of the fractures up to the depth of 200 to 300 meters below ground level, resulting the over-exploited or critical level which is going towards that side. So this is one of the reason why most of the Indian areas are going over-exploitation or critical stage of groundwater because of their over-utilization for the agricultural purpose or whatever the required for drinking water as well as urban water needs. So the increasing dependence on groundwater for various use is also one of the concern. As I already told you, as the over-exploitation of groundwater is happening, groundwater contamination is also one of the concern to be monitored. So because of the over-exploitation, the earlier water was available at shallow level within a depth of 20 to 30 meters through bore wells. Now, in parts of Kolar, in parts of Chikballapur and other areas surrounded by Bangalore, the groundwater level have gone drastically down more than 100 meters below ground level. So the stage of groundwater exploitation, extraction in these mandal, taluka is more than 70% and requires attention for artificial recharge investigations. So as you use more and more groundwater, deeper groundwater, the groundwater contamination with respect to arsenic, fluoride, iron, and nitrate, salinity is also one of the major growing concern in India. So why groundwater is scarcity is happening in India? So these are the few points I have given with respect to climate change, overconsumption, pollution, inefficient of water management are major concern in declining the groundwater scenarios. Nowadays, as our Ilango sir expressed, so climate change is one of the reason for declining groundwater levels, for depleting groundwater scenarios across the globe. So most of the sessions now, the climate change is one of the major topics which are discussing what exactly has happened in the water sector due to change in climate. So overconsumption of water is also one of the reason for water scarcity. As I already told you, increase in population resulting increase in consumption. So increase in agriculture area is also resulting increase in groundwater usage. So resulting the overexploited area increase. So pollution is also one of the reason for contamination of the water users with which is source of industrial waste, agriculture runoff, sewage also one of the reason for pollution. So inefficient water management is also one of the reason for water scarcity, where you can see poor infrastructure, inadequate water shortage, and lack of proper irrigation techniques lead to a significant water losses and inefficiencies. So with respect to inefficient water management, it is a high time for implementation of effective plans for implementing artificial recharge plans in as well as agricultural land as well as in urban areas. Going towards the water scarcity, the overexploitation of aquifers, unequal access and population growths are also main causes for groundwater scarcity. So with respect to overexploitation of aquifers, as I already told you, 2-3 decades back, we used to have the water within our dug wells, which is near to us. Now, as the growth, population growth, as well as agriculture activity increases, over pumping of groundwater, we are punctured the groundwater sources, resulting deepening of water levels. And also in most of the area where overexploitation is happened, the fractures up to 150 to 180 meters have gone dry, which is the high which is highly required for implementation of the artificial recharge plans. So with respect to unequal access, so the water resource can lead to social and economic inequalities with marginalized communities often facing the brunt of water scarcity. This is also one of the important causes of groundwater scarcity. As I already told you, population growth as the global population increases, and also as the population increase in India, the scarcity of groundwater is also naturally increased with as the groundwater is available with limited sources. What are the remedial measures? Already we have noted the scarcity, reasons for scarcity, how you are to take up the action plans for arresting these groundwater, whether it's with respect to surface water or with respect to, in case of groundwater, suitable remedial actions to be taken to safeguard our water resources. Coming to the points, water conservation, improved water management, and rainwater harvesting. Water conservation is one of the major things to concentrate for effective implementation of the artificial recharge structure for further development in agriculture, industry, and also household consumption. So one of the reasons why we need water conservation is this. So improved water management such as dams, canals, water shortage facilities can also manage water resource more effectively. How, if you take a watershed management activity compared to the previous decade or compared to last 4 or 5 years, after implementing the suitable artificial recharge plans, how it can be improved with respect to water level usage as well as further reduction of overexploitation. So rainwater harvesting is the talk of the town now. Wherever you are visiting nowadays, how to harvest the rainwater is one of the major topic. So whether with respect to the flowing water or the stream or with respect to your rooftop, it is a high time to harvest the water for our benefit with respect to recharge to the subsurface or to our household activities. So water use and climate change mitigation and educational awareness is also few remedial measures to eradicate groundwater scarcity. So education and awareness is one of the important parameters nowadays to create an awareness among public and also on the learned masses. So raising public awareness about water scarcity and also so informing about the importance of water conservation and how to be used is a high time to educate among the public for effective management practices. Coming to the groundwater conservation through artificial recharge, how the artificial recharge can be implemented in a suitable area, whether it is in terms of a hard rocks or soft rock. Now I'm mostly talking about the hard rocks which is falling in the southern Indian subcontinent. So here how the rainwater harvesting can be taken up with various techniques. So it involves the collection of water from the subsurface on which it falls and subsequently storing this water for the later use, whether in terms of subsurface seepage or it is for a household. There are sources is surface runoff and also through rooftop rainwater harvesting. Through surface runoff means wherever the water, when the rain falls, the water which is falling along the streams, that is surface runoff. The rooftop rainwater harvest is the one method which we are normally using our household. So that is the rooftop rainwater harvesting. So what are the techniques which we are normally adopting in this year is, so the surface storage techniques and subsurface storage techniques and combination of both. So let's discuss about in these techniques in details. So these are the few artificial recharge methods which are direct, indirect and combination of both. So under direct methods, surface spreading method, subsurface technique is used under this. This slide is telling you in detail which drainage order is suitable for what kind of a structures. So you cannot simply propose a check dam in first order stream because of its high density, drainage density. The life of the check dam in first order stream is not valued, and also the check dam which are recommended along the third order stream or a major second order stream is worth compared to the first order streams. So this is how you can able to analyze the artificial recharge method with respect to the direct and indirect and both combinations. Here you can see the flooding, ditch and furrows, recharge basin, runoff under surface spreading method, whereas in subsurface technique, subsurface means below the ground level. So where you can see injection of wells, gravity hard recharge wells. And also in the indirect methods, induced recharge method is also one of the important among apart from aquifer modification and groundwater conservation structures. So each and every structure needs to be scientifically selected for its effective implementation and also review in the later stage. So what are the factors which controls the sustainability of artificial recharge? The quantum of non-committed sources and runoff is available, which is in a suitable form. So rainfall pattern, even the rainfall which is less than 400 mm in an area, though that area is highly deficit, artificial recharge structure is highly necessity. So in the state of Karnataka, in the state of Bangalore and surrounding areas, the rainfall is around 800 to 900 mm. Though 900 mm is high rainfall, because of the insufficient artificial recharge structures, it is unable to recharge below the surface, resulting in the more and more implementation of the artificial recharge schemes to lift the groundwater levels as the area is falling under poor exploitation or critical category. And land use and vegetation is also one of the controlling factor, and topography, terrain profile, soil type, depth, thickness of the weathered zone, this point is very important. Thickness of the weathered zone at what, when you are proposing a suitable artificial recharge plan, what is the thickness of weathered zone is very important. This helps to arrest the water movement below subsurface. Just like if the weathered zone is increased, with the soil cover is increased, with the sand cover is increased, the life of the structure, the utility of the structures and benefits is increased for a period of time. The hydrological and hydrogeological characteristics, environmental, ecological impacts of air schemes are also major controlling factors for the sustainability of these artificial recharge methods. So these are the few points where you can see the surface storage techniques. So there are direct use underground tanks and filters which you are normally using in rooftop rainwater harvesting. For the recharge purposes, which is required for subsurface seepage, the ponds, check dams, gully plugs, nala bunds, weirs and contour trenches. These methods are these kind of structures are very much useful for recharge purpose. So these are the few live examples, field photographs, which are showing surface storage techniques, either check dams, percolation tanks, and contour trenches. Contour trenches normally we see in a altitudinal places. So these are the important structures for arresting the surface water flow, which are directly contributing to the groundwater storage, resulting the adjacent wells which with improving groundwater level and also its sustainability along with the increase in their yields. Whatever the dried fractures which are noticed during drilling, which have recharged due to the construction of these kind of structures, you must have noticed in one shower of full rainfall, most of the bore wells are going to be recharged if it is properly constructed. In one of my case studies in Madhugiri district, so in the year 2014 and 2016, so before that there was no proper rainfall in that area in the part of Tumkur. After proper implementation of the AR structures, one of the big shower has resulting the fulfillment of whole water bodies in the area, and also the implementation of several artificial recharge structures have helped uplifting the groundwater levels. One farmer was really appreciated. His 30-year borewell got rejuvenated because of one night's rainfall. So since last 11 years, there were no tanks filled in those areas. With one entire night's rainfall, his whole borewells got recharged. Even the borewell drilled at the depth of 90 feet got rejuvenated, and also he lowered the new pump in that borewell. Even that farmer, I would like to state here, that farmer is highlighted, sir, if the next year also, if I get the same kind of a rainfall in this area, whosoever are present, my sons and relatives who are migrated to Bangalore, they come back and start their agricultural activities. So this is the one of the high impacted reasons of directly implementing the ER's artificial recharge schemes in any of the area which is suitable, especially in the hard rock terrains. So this is the few photographs of check dams and percolation tanks and also contour trenches in the suitability areas. So this is the surface storage techniques where you can see gully plugs, nala bunds, which helped to control the flow of water and directly recharge the groundwater aquifers. Afforestation and also pasture development on barren land also very much useful in arresting the further flow of surface water, which directly recharges to the deeper aquifer systems. So these are the few benefits of surface storage techniques. it has several direct benefits to providing water and food for cash crops, increasing groundwater recharge. This is one of the important point which are the resultant of surface storage techniques, reducing storm water discharge, urban floods, reducing seawater increase in coastal areas, and of course we can say reducing electrical bill when there is no pumping in some of the states. And with the possibility of contamination, cost of treatment, storage, loss due to evaporation is also some of the benefits of surface storage techniques. So with respect to subsurface storage techniques, the recharge pits, recharge trenches, dug wells, bore wells, recharge shafts, injection wells, and lateral wells within the dug wells are falling. These are the few structures which are falling under subsurface storage techniques. So you can see here under subsurface storage technique, recharge pits with shaft is also, it is one of the point recharge structure where most of the dry bore wells, dry hand pumps which are drilled by Government of Karnataka have been implemented. You must have seen in many villages this kind of a artificial recharge is common. So in also dug well with recharge filter, whatever the water which is flowing from this side with a suitable filter technique, it reaches to subsurface. So this is the subsurface storage technique with trench and recharge. The bore well which are drilled adjacent to this trench, the water which is moving from here with the certain filtration beds, it directly moves to the recharge well and improves the water levels and also the subsurface scenarios. So these are the advantage of subsurface storage techniques. I don't want to tell in detail, so because of the time constraint, so majorly the groundwater level will definitely increase, which is the resultant of sustainability of bore wells as well as dug wells with enhanced yields, resulting the reduction in drought condition in a part of overexploited areas, and also reduces runoff, which is one of the cause of soil erosions. So these are the few structures which fall under indirect methods. Those are the recharge basins, flooding, ditch and furrows, channel methods, recharge by irrigations. So this is the field photograph showing ditch and furrow method, and this is the bench terrace practices which normally we will see in sloping lands where there is a slope is a gradient is high. So depending on the land slope and also width of the individual terrace varies with the different dimensions. So this is the vertical elevation differences and width terraces. This normally we can see in a highly elevated lands in part of Coorgs or in part of North Indian and Northeast part of India, where this kind of a terrace culture is normally practiced and for the paddy crop, where the groundwater is easy to flow along with the recharge. So adequate soil cover for bringing them in under irrigation is also one of the important factor to be considered. So this is the field photograph showing contour trenches, which is normally seen in hilly stages. So hilly ranges. This is one advantage. It reduces the soil erodibility, and the second, it arrests the water movement, surface water movement within the same place. This is the staggered trenches where you can see these alternate points. You can see the trenches to arrest the soil erodibility as well as the recharge of surface water flow. So this is the gully plug with the sunken pit, where the gully plug is very important to arrest the soil erosion is as shown in the picture. These are called as a gully plugs with the pebbles. So this is the nala bunds with gully plugs. This is the sectional view of how the gully plug can be planned along with the different sloping patterns, which is normally in first order or second order streams. We are recommending this. So this is the Gaussian structure. We will put the boulders along with the meshes to arrest the surface water flow, which is normally located, finding it in a medium elevated portions to arrest the immediate flow of through a streams. So there will be a gradual seepage of water, but it is not a sudden seepage, which is the resultant of groundwater recharge through subsurface. So this is the percolation tank view, which is naturally constructed between a hill and this side, where the water is being obstacled and for a direct groundwater recharge. So these are the different structures: Gaussian structures, percolation tank, check dams, subsurface dikes, where the thickness of the sand cover is increased, where the subsurface dike is recommended, and other structures you can notice here. So this is the recharging of artificial recharge, rooftop rainwater harvesting, how a prominent dimension of a house can be recharged if it is properly implemented, which is directly or indirectly recharging the subsurface or regular house usage purpose. So this is a clear picture how a rainwater can be harvested through their rooftops, resulting the for their domestic purpose as well as subsurface recharge. So as I already informed, public participation is very much important in groundwater sector, in artificial recharge conservation structures. So as we already told.
Jagdish, yeah, please can you conclude in another 1 or 2 minutes?
Yes, sir. Yes, sir.
Dr. Srinivas, yeah, sorry.
Yeah. I'll just, this is the last slide.
Okay,
So
thank you.
people's participation is the need of the hour for implementing and raising the awareness on whether it is a groundwater or surface water. So how the people participation in arresting the water and knowledge on water usage, it also depends on as a individuals. You can see the field photographs in part of Telangana, and also this is the common feature and also in most part of the Karnataka, where they are giving the knowledge and sharing the knowledge in groundwater conservation and its effective management. If a farmer can manage his aquifer at village level, it is a very good resultant of the things which is expandable in another areas. So this is the few slogans on rainwater harvestings. I don't want to read, it's a self-read. So that's all about our groundwater scenarios, scarcity and remedial measures, and how the artificial recharge is beneficial in arresting the surface water and also arresting the proper utilization of the rainfall. So thank you very much. Thank you, sir. Over to you.
Yeah.
Shall I exit?
Thank you so much for your very informative and elaborative presentation on global water resources scenario, groundwater status across the globe as well as across the country, and in particularly across the state also, and various measures for rainwater harvesting and groundwater recharging structures, both surface and subsurface structures you have covered very nicely with good examples and good case studies. Thank you so much for your elaborative and informative presentation once again. Thank you. We'll be in touch with you.
Sir.
In future also we
Sure,
require
sir.
your service for the benefit of our state. Since you are from also from Karnataka, definitely we will try to utilize your services for our future studies. Thank you very much, Dr. Srinivas, joining for this webinar from Hyderabad.
Thank you, sir.
Thank you so
Thank
much.
you for the opportunity given to me. I'll be continuing your association
Definitely.
and
Definitely.
Institute Association. Thank you so much, sir, for the opportunity given to me. Yeah.
Thank you.
Over
Thank
to
you
next
so much for
session.
joining. Yes, thank you. Thank you so much. Now we'll move on to next session by Dr. Jagdish, Farmer Scientist from Regional Remote Sensing Service Center, RRSC, ISRO. We'll be talking on space technology for water, surface water structures. What Dr. Jagdish?
Yeah.
Yeah.
First,
Can you-
share option is not given so far.
Mr. No, it is there. Option is given.
No, I am trying. See, entire
Oh.
screen I am going. Either for window or Chrome tab, it is not appearing.
Just please wait. We'll arrange for the same.
Yeah.
Now it's been given.
It's
Dr.
given.
Jagdish?
Yeah.
Yeah, it's given. Yeah, cost. Yeah.
Still, it has not come for me. Share option. Present screen I pressed, and then all the three are appearing: Chrome tab, window, and entire screen. But
Really?
below share is not highlighted. No, most probably previous person is not logged out.
I have logged out.
Okay. Okay. Thank you.
Welcome. Sir, if you find any difficulty, you can share your PPT with the organizers. So they will.
Yeah, I can send it. I can send it.
I think that is a good idea.
I can relog also. I will send it to the PPT to you people because that is faster.
Dr. Jagdish.
I can
Can
see.
you?
I'm sharing the PPT to you.
Yeah. Studio.
Yeah. I will. It's around 6 MB. It is coming now. Yeah, I have sent it. Please see.
Just a minute.
Yeah.
To which email ID you have sent, sir?
Your KSC.
Because you have not received it.
Yeah. Please send.
Otherwise, please send it to MNR
MNR
KSCST.
MNRAO.
MNR at KSCST.
No, MNRAO. MN Rao.
Okay.
MN Rao at kscst.org.in.
Okay.
MN Rao, MNRAO at kscst.org.in.
MNRAO
At
KSCST.org.
.org.in.
.in.
Please send it.
attached.
The email is in the text box, sir. Message box.
Okay.
Yeah, it's there. Yes, correct.
I send. It is coming. Loading. Received?
Wait. Yes. It has come. Please wait.
Yeah,
Just we are-
please.
Okay.
Okay. Okay, thank you. I thank KSCST for giving me this opportunity through Dr. Vijay. So this is all about water conservation and use of space technologies for digital India. Okay, not for non-digital India. Next slide, please. So World Water Day is glaciers monitoring. Some 2 slides are there on that. Geospatial knowledge infrastructure, space remote sensing, communications, navigation, drones, digital photogrammetry, digital image processing, signal processing, sampling technology, soil sensors is another set of slides. Then water quality technology, some 11 slides. And then microsatellites and CubeSats, 2 slides. And then various other conclusions are there in that. Next slide, please. So we have what is called a geospatial knowledge infrastructure, which is brought out by the help of space technologies, which is a standard for the entire world. People are following this. So various elements of each one of them, we are filling it through either drones or through aerial surveys like Airbus surveys or satellite services. Okay. Next. So remote sensing is done through this electromagnetic, that is sun's rays. Okay, sun's rays are the composition of not only visible light as we see visible light, but also ultraviolet, including infrared, microwave, and radio waves. Okay, we are making use of that remote sensing and geospatial applications. Next. So, because it is Water Resources Day, when I went through the various research articles on glaciers monitoring in the Himalayas, Himalaya can be considered as a third pole of having so many glaciers in its pocket. Okay, that's why it is called as the third pole, other than Arctic and Antarctic. So, it has around 9,575 small and large glaciers in the Himalayas. So, satellites are the only methodology to monitor them. Okay. And they affect 1.3 billion people of the water because of the glacial water and other snow-fed rivers. Next. So the entire world scenario on March 19, 2025, Nature has published an article, that is yesterday, day before yesterday. There they have told that only 5% of the glaciers have glacier volume has gone out of picture. Only 5% of the storage has gone out of the picture. So is the thing to worry or not to worry? I do not know. I have not read much on climate change and all that because I have taken some books from IASC and kept the 3 books under my pillow all these 15 years. So I cannot distinguish whether 5% storage loss in the entire 50 years is matter to concern. Okay, and all types of satellites are used in identifying the glaciers. Human beings are also used for taking pictures at the edge of the glaciers. wherever it is possible. Sometimes drone also very difficult to reach. With that, this thing, and we have a need for avalanche monitoring apart from glaciers also for India. Next slide, please. Next slide. So we use optical images for water quality. Now, water quality is very important because everywhere there is a rise and everyone cry for water quality. Sentinel-2 data, MODIS data, Landsat data, thermal band. Thermal band, we are going to have a new satellite called Trishna from France, and then Nizar for soil moisture. Okay. For water quality point of view, Sentinel-2 images, it is possible to routinely conduct large-scale water quality monitoring of different size rivers. Okay, it need not be in the ground, like Central Ground Pollution Control Board or Karnataka State Pollution Control Board has its own stages. So there are point here, satellite also can monitor it. Next slide, please. Okay, satellite has monitored the permanganate, total phosphorus, total nitrogen from Sentinel-2 images in large part of 100 kilometer by 100 kilometer area. Maybe Kissimmee River, some other country. See, the river, all along the river, they have given you a graded value of all these. So where is the point measurement by pollution control boards and the continuous depiction of water quality on different dates by satellite imageries? Okay, that is the advantage. Next slide. Now the water quality has been so much improved. The people will put in the lake a handheld sensor for calibrating the satellite data about the water quality of the entire lake. So one sensor measurement just beside this inspection bridge, and they correlate it with the imagery, okay, which is obtained from things like Sentinel or even Planet Labs satellites. Okay. Then hyperspectral remote sensing is done. Next slide. So the best way is people have a lot of belief in drones, and the government of India is also giving one drone for each village. They have in their kitty that they have to give one drone for each village. So people can make use of the drones for finding the water quality also by putting appropriate sensor in that. Then appropriate activation function called TANH in AI, that is artificial intelligence, can be used for the ratioed satellite images. So which will bring the scale from 6 centimeter to 60 centimeter sampling first. Afterwards, 60 centimeter will be upgraded to some 10 meter or 20 meter resolution of the satellite images. Next. Yeah. So remote sensing can be used for even pollution, microplastic pollution, floating marine macro litter. That has become major factor because in the marine, the ships are getting stopped. Their drag has come down because of the floating plastics. Floating marine macro litter also can be monitored using in situ samples taken from the field, that is marine boats, and then using synthetic aperture radar and LIDAR. Okay. Next. So a meta-analysis for microplastics for agriculture regions. You see, we are happily putting greenhouse gases, greenhouse agriculture, and also plastic culture is also in some places it is highly useful. That will help. So plastic mulch in the crop production and area covered by plastic materials like greenhouse, when once they disaggregate and they get spoiled, and where is the disposure? Disposure will be once again plastic contamination. Okay, that can be analyzed using satellite images. Next slide. See, these are the technologies that are available for measuring the microplastics in agriculture. Okay, this is called Menta-Ray sensor that is already developed. It has both electronics as well as computer science in that. Okay. Then Monga Bay, another one. Okay. So many startups can come throughout India for using these things for measuring the plastic pollution, microplastics pollution. Okay. Next. So microplastic pollution in agriculture, plastic greenhouses mapping using the satellite remote sensing is shown here for a large area of 100 by 100 kilometers. Okay. So throughout Karnataka, you may have some 50 images. So those 50 images should be able to say what is the plastic greenhouse and what is the open crop land and what is the man-made surface and the bare soil. You know, that is the best way to monitor the both surface water quantity as well as quality. Next slide. This is the same as the first one which I showed you, that is permanganate index. There I had given a different diagram. Here this is for different regions it has been done. Next slide. And for finding the microplastics, people have used carbon nanotube sensors, because it is material oriented thinking nowadays. Without material science, nothing can happen. And material science only can bring in the large number of small satellites. For the younger generation who has a startup and who wants to have a small satellite constellations, up to 200 kg or 150 kg, they can use carbon nanotube based materials, as well as some 2 new materials also have been found out. I could not include in this slide. They are the latest. So a lot of material, this thing is required for monitoring the water pollution as well as for helping the satellite technology. Okay, next slide. So Internet of Bio-Nano things, that is the nanotechnology now has turned as a bio-nano things, they call it as. A cell is equal to an IoT. So a lot of things are there to learn from this, because we are putting IoT everywhere for agriculture and even for monitoring water quality. So it will be of great use, this technology. Next slide, please. The use cases of small satellites, which I was talking, less than 150 kg, which the younger generation is going to launch. ISRO will not launch because it has the agenda for launching large satellites only. So that's why Government of India has given it to the various startups, academics and the startups to use the CubeSats and micro satellites up to that. They are going to help the forest fire monitoring, soil moisture mapping, supplementing the NISAR, which is a large satellite which is going to be joint venture between USA and India, which is going to be launched. Okay. Then marine surveillance for pollution of oil slicks, fisheries control, illegal immigration, drug smuggling, cross-border crime, everything can be found out using the CubeSats and microsatellites as complementary to imaging floods, droughts, earthquakes, landslides, water quality, and microplastics. This is a thing. That's why material science has to improve. Quantum communication to several ground stations at a time. Yesterday, it was news for knowing that satellite can communicate to the ground stations very well. That is the best part, because all our secret data can be encrypted in that, and it will be country specific or state specific. Next slide. Next slide, please. Yeah. There are so many use cases for CubeSats, deployable techniques, energy storage, lithium manganese oxide, all of these materials study should be done. And also robotics and on-orbit operations are possible. That is International Space Station, small sat computing, hybrid computing, space propulsion, radar technologies for Earth observation, formation control of small satellites, thermionic observations, solar flux, solar wind plasma, they are all helpful technologies for monitoring the water. Next slide, please. So ISRO, NRSC, RRSSC has carried out the following along with Central Water Commission, and I request the state government to make use of that. Available yield in river basins, for all the river basins, the data is available. Both remote sensing data as well as field data that is collected for the past 50 years. They are available with Central Water Commission. They can go and collect it there and make use of modeling and monitoring for water quality as well as quantity through the students as well as the existing staff if they are willing to do it. Existing staff have become outdated because they have no knowledge or training or capacity building on satellite remote sensing that is needed. Recently, I was very happy to note that Karnataka State Natural Disaster Management is associating itself with our VSSC one center, ISST, that is a university by itself, and identified droughts. So that is the right take. They have chosen them. So Soilmeister maps, when they come, they will identify the drought in a far better way than anything else. That's good. Reservoir sedimentation studies have been done for finding the remaining life of the reservoir and also the main system management. This is my research itself. And we have to apply it to all the other reservoirs in the country. That will bring down around the advantage of around 4,000 crores per season. Water accountability will increase. So groundwater potential assessment is already done by ISRO using potential groundwater potential maps. Watershed water management is the need of the hour. Stormwater management, drought management we have done through agricultural drought bulletins, giving it to development commissioner, and it stops there and is stable. It never seeps because he has another several set of other criteria to monitor the drought. Okay, next slide. Next. So basin-wise water resources, what we assessed was the annual water resources available in each basin. Basin means Tungabhadra Basin is a part of the Krishna Basin, sub-basin. In Tungabhadra, Bhadra Basin is there. In Bhadra, some more catchments are there. So the spatial data, when it is available, you can have it in your executive office or even in a university. Okay. And then try to use that for modeling the water quality, water quantity, and whatnot. So this has already been done and given. And we are waiting for implementation of these things from the field people. Okay, they are stuck somewhere, either Central Water Commission, they are stuck, or in remote sensing, state remote sensing center, they are stuck. Okay, next slide. So for that, we have used digital elevation models, LULC, soil texture, not like COSLA, when they used only the gauging stations of Central Water Commission. This time we have used all these things. Rainfall temperature, groundwater flux, reservoir flux, river discharge to arrive at those water assessments, that is available water yield per year, compared with the Central Water Commission's measurement at the end point when it joins the river. Okay, or say some 50 kilometers away, say. Next slide. So this is the Krishna Basin, which map I had hung in my RRSSA office and waited for 20 years for the people to come and see them. Except some school students and college students, nobody came and saw those maps. Not for the visual happiness we were waiting. Here all the reservoirs of the Krishna Basin are seen. Tungabhadra, then Bhadra, then Nagarjuna Sagara, then Shishalam, then Upper Krishna, all the projects. Linganamakki also this side. Okay. Then Malaprabha, Ghataprabha, all of them are seen in this. Okay. This map we had put it on a large wall and 1:25,000. At that time, digital was not the order. Now digital is there. You can easily scroll down and see. Next slide, please. So January, March, May, July, September, November, if you put those maps, you can see how much of agricultural crop has grown in the command as well as in the non-drought affected areas. So that is the best way to monitor the resources. How the water is getting depleted, how the agriculture is getting improved. Next. This is once again Tungabhadra Reservoir, irrigating around 2 lakh hectares. 1.5 lakh hectares on the left side and 2 to 3 lakh hectares this side, and totally around 5 to 6 lakh hectares in the Tungabhadra, including Andhra Pradesh. Okay. Next slide. groundwater potential maps. You must, if you just log into, you can use. So many IT people will ask. They ask us, and we will give them, because we know where they are located and easily downloadable. You can try to make them more usable by adding the latest borewell data. You have to update those maps with the borewell data and then reconfigure and read them. Next slide. See, global environmental commons, we have to identify biodiversity, atmosphere, oceans, and the land. See, Gomala alone is not the common land. Now, biodiversity is the common land, atmosphere is the common, oceans and land. These are the global environmental commons also. We have to monitor using satellite remote sensing for the sake of water itself first. Next. Yes. Most important thing is India's position in achieving the sustainable development goals as per few existing standards of India and the world. We are 129th country, 120th country in the entire world of 135 or 140 countries. Okay, that is our level of sustainable development. In 2023, it is published, and top 5 countries are Finland, Sweden, Germany, Denmark, Belgium, and bottom 5 are Liberia, Sumatra, Chad, South Sudan, and Central Africa. Luckily, India is not there. It comes in the top 10 only. So, next slide, please. And environmental crimes have increased in India. That is, water-related crimes are also quite a large number. They are given here. In 2021, 136,000 cases were there totally. Different types like Indian Forest Act, as per that, then Wildlife Protection Act, so many, very small. Okay, large thing is there only in air and the water. Okay, and they say that 38 years and 3 months will take to resolve all those issues in front of the environmental crimes. Supreme Court has given a mandate to the central government saying that I cannot handle this issue. Even IAS officers and Indian Engineering Service officers also cannot handle. Let us have an Indian Environmental Service. They had written that. I don't know when the government of India is going to wake up and do that job. But anyway, that is the Supreme Court version. Okay, next slide. So we have so many websites wherein all our spatial data is available. Now, which you can log on, and most of it is free of cost, and you can start experimenting and make the common man give the education at your own level. Next slide. These are all websites you can always go through. So, Government of India web portals for assessing the risks in the water sector before intervention of digital technologies commence. Okay. Here, integrated water resource management is the need of the hour. And GRACE satellites can assess the water fluxes monthly, groundwater fluxes at 24 kilometer by 24 kilometer land area grids. They can provide the ideas of movement of water in the grid considered. Okay, Central Groundwater Board can make use of this data and see their watersheds, aquifers, how much water they exchange in each season. Next slide. Next slide, please. And we have a lot of applications from the satellite which will help the water sector only. Aviation is there, maritime is there, land warfare, space, weapons. These are all the technologies which the satellite can give. That is called PNT technologies. Unless PNT technologies are used, you cannot counter the cyber security. From cyber security and digital forensics point of view, this is highly needed. For example, water, when you take, I am taking only water now. Next slide, please. Water is a specific subject for a water resources person only. Nobody else can touch it. Okay. You say a cyber security fellow, he will do what he will do. See, he has not studied the simulation of the watershed. He doesn't know how to develop a test bed for that. Water box, SWAT, WADI, EPANET, CPA, so risk not. it is as good as teaching him one more water resources engineering course, whether it is for computer science or electronics fellow. So it is not possible. So other people, all of us have to share the burden now. It is not the question of engineering alone, it is a question of science, and it should be interdisciplinary. So cyber attack and detection models, okay, a model-based security analysis, risk and resilience management. See, for example, risk itself and resilience, they are so complicated. Even now, we don't have flood risk maps for this country. Okay, next slide, please. So this is the way I have explained there, how the risk reduction can be done, and the risk analysis and evaluation toolkit has to be done for cyber security point of view by providing the fences and walls, motion detectors, camera surveillance. It is all at water centers, I am telling you. Patrols, binary contacts, secure doors and windows, entrance, because we have SCADA, we have put in our Krishna Basin. SCADA to protect, we need all this. Cyber security is most important for us, because when we operate, our people are very happy in that part of the Krishna Basin, Navarund and Nargun, that they have got SCADA and their problems are solved to at least 50%. Whoever wants the water, they can get it, whichever area it is, in 150 kilometer area. So that is the beauty of digital India. SCADA is there. Karnataka. They are trying to do best things by there. Only thing is knowledge transfer from the vendor to the government officials has to take place now. So next slide. So risk, same thing is continued. Cyber physical systems. Next slide. Flood risk maps from satellite data. We have given the flood inundation maps for the past 30 to 40 years from ISRO. Not even one person has tried to get the flood risk maps from our data. So I have given the methodology here. That is my way of dealing with the subject. Don't wait for consultancy. Waiting for consultancy in India, we have to stop consultancy for 5 years. Then only things will improve. Otherwise, we'll go on waiting till your death. People will come to me for consultancy, and you will never transmit anything to the people. See, consultancy can be given only if the person understands your consultancy, So this is flood risk maps can be prepared within no time for say 6 months or 1 year for the entire India. So that becomes a small scale startup itself. So somebody can try that and do it. Next slide. Same thing continued. How to go ahead with the flood risk maps. Next. Yeah, circular economy has come into picture now, not just because it is a fancy word by economists. Circular economy have got so many branches: resource-based circularity, technology circularity, scale-based circularity, and ecosystem-based circularity. Luckily, world people have done some research on resource-based circularity for USA and China water resources, and they have come to the conclusion that existing water is to be conserved. Otherwise, they will also go out of this thing. Just like America disbanded it 150 dams and reservoirs recently because they have become old. Okay, so China, so they have warned them based on the resource-based circularity. You have to stop using the water in some sectors. They have given. Okay, so studies are to be done for various other countries in the world. We can do that. Next slide. Next slide. So the second green revolution for the water technology has to come through ICT technologies. Okay, drone, geospatial, smart water grids. Smart water grids have to come. Next slide. What those smart water grids will do? They can measure from the satellite, because people have come to the conclusion that irrigation alone cannot solve the problem, though it has increased the productivity. Green water productivity needs to be increased. Is from ICRISAT, world body. So for food security to happen in the digital agriculture, in which irrigation is also a part of it, and the vapor shift and improved T/ET ratio are to be obtained only by using satellite data and the sampled ground truth data. Then only will become food secure. Otherwise, we will not become. Yes, next slide, please. eco-legal order. The existing legal order, that's what that environmental board is, pollution, environmental, so many cases are pending, I told you, that is all happening because our law system is only machine applying hierarchy of norms which are there, which can be easily done as AI. But we are not doing that also. We have to go for capital to commons, commons as a capital, common in the law, Naples, Paris, etc. They have done that. We have to apply them for water, solar farms and wind farms and community land trust. Now, generative ownership should be given to the people than extractive ownership. Okay, next slide, please. Another 5 slides are there. So, integrated water resource management, we have to have the ignition in us. How to ignite ourselves. For igniting, you have to use our public digital databases. Just like public digital infrastructure, which last year they did. We have already UPI is one of the public digital infrastructure. You have to have water bases like this, ignite, and then integrate them through AI and ML and ICT and SCADA, cyber physical systems, then innovate the rain-fed farming through vapor shift and cropping systems and soil carbon. Okay, water productivity should be increased. And then we have to integrate first the different departments. CGWB says assessment as critical and other things, that is already challenged by several other scientists, saying that that is not scientific. Okay, so one Vidyashankar, I think, P. Vidyashankar has claimed that, and including another person from UNI, International Waterman. And for my experience, CGWB watersheds are not coinciding with the watersheds given by ASLUSC. So how can I correlate the flow of aquifer from All India Survey, Land Use Land Survey watershed to the Central Groundwater Board watershed? Difficult to integrate. So many problems are there. When once we come, we have to remedy all of them and go ahead. Geospatial is a smart technology. We have to have them develop the workforce. Next slide, please. Yeah, the last 2 slides. The most sought after labor skills in the 21st century identified by the world are resolving the complex problems, ability to negotiate, adaptability, keep an open mind, decision making, emotional intelligence, creativity, initiative, inquisitive, critical thinking. They all form the digital labor skills. We are not transmitting them in the education scenario at all. People have already taken courses. I didn't add those slides here, how to take the courses and how to monitor these. That should be included in the new education systems, wherever it is, whether it is state, central, education system, it should be introduced. Okay, next slide, please. The 8 key skills for digital intelligence are given in this slide. Okay, one is digital use, digital identity, digital rights, digital literacy, then digital emotional intelligence, digital security. There are so many branches in that. So all of them are included in the syllabus. Okay, next slide, please. So the conclusion is reduce the workload of the socio-political leaders by encouraging them and facilitating them to use up-to-date policies, design, analysis, interpretation, legal and regulatory aspects, and redesign for all the interdisciplines which come under each sector: water, energy, minerals, ocean, wealth, etc., which come under digital transformation. So we have to enable our socio-political people. They are the people who are trying their level best, to bring equity in sustainability in the society. So we have to help them in bringing, for example, if you say climate change, I can give you 34 policies which are implemented first before going for climate change adaptation. Climate change is one thing, climate change adaptation is another thing. So for that, 34 policies are first implemented. Afterwards, only according to that they go. Okay. Topics, subjects like digital labor skills and transformation, AI and ML, geospatial technologies, non-destructive evaluation technologies, cyber security. Any of our dams are having any ND equipment? No. Contractor says, no, you cannot implement here. It is not in the tender. Why it is not included in the tender? God only knows. So we don't have our dam safety equipments kept in our dams. We are doing the analysis through CWC for dam safety by finite element method. Only if the dam fails, how many people are going to be affected, how to protect them. So why critical methods? You can have a preventive method by putting the non-destructive techniques. You have not to. Railways have put it. Indian Railways have put it. Okay, digital forensics, cybernetics, design thinking, sustainable development in all fields should be the basic subjects in graduation for 2 years, and remaining 2 or 3 years, you can go for specialization for job-specific, outcome-based education. And some people want to become a Newtonian and Einstein type of science subjects that can also be included and make them better scientists in that field. And appropriate diploma, degree, post-degree, doctoral and postdoctoral studies can be in any AP or any education policy of the state or universities. It should be the need of the hour. So blueprints for water sector should emerge, including sustainable digital agriculture, food, water and energy, sustainability, keeping circular economy in view, and sustainable social networks using ICT and beyond new technologies. Okay, this is to be holistic, top-down approach. The water approach should be from top-down, actually. Now in the digital era, especially. Otherwise, Germany, they had to dismantle all their networks, ICT networks, after 3 years in their railways, German railways company. Just 3 years back, they dismantled, and now once again they have put the re-ones. So that's why we have to work from top to bottom, so that that dismantling will not happen. Thank you very much for the opportunity. Any questions, I am ready to take. Thank you. Once again, the Karnataka State Council for Science and Technology and Dr. Vijay for giving me this opportunity. Yeah.
Thank you so much, Dr. Jagdish, for giving very useful presentation on utilization of space technology, especially remote sensing technology for assessment of both surface as well as groundwater resources in our country as well as in our state also. Thank you so much for joining. Then, before moving on to last session, proposing a vote of thanks, on the occasion of World Water Day 2025, let us take oath on conservation of water. So I will be sharing the statement for oath taking on the occasion of World Water Day. Yeah. Water pledge. Just move on. Yeah, thank you, Dr. Jagdish. You can mute.
Okay.
Yeah. So, on the occasion of World Water Day, let us take what water pledge. I take an oath to conserve water and to use water wisely. I pledge to consume water judiciously and not waste even a drop of water. I will treat water as the most precious treasure that I possess and consume it accordingly. I pledge to motivate my family, friends, and neighbors to use water wisely and not waste it. It is our planet and only we can save it. Thank you so much. And I will move on to next session. I request Mr. Venkatesh, our senior colleague, to propose vote of thanks. Over to Mr. Venkatesh.
Yeah, thank you, sir. Good evening, everyone. As we gather here to celebrate the Golden Jubilee celebrations of our Karnataka State Council for Science and Technology, I am honored to propose the vote of thanks for this momentous occasion of the webinar series. As we informed, this is the third webinar series. First and foremost, I would like to express my sincere gratitude to our esteemed speakers for sharing their invaluable insights on the topic of water technologies and on the occasion of World Water Day 2025 and on the occasion of Golden Jubilee Webinar Series. I extend my heartfelt thanks to Professor Praveen Ramurthy, Professor, Department of Materials Engineering and Chair, Interdisciplinary Center for Water Research, ICWAR, Indian Institute of Science, Bangalore. I thank you, sir, for your enlightening perspective on interdisciplinary research Center for Water Research and in water conservation and management to all of us. Thank you. And I also thank Dr. Elango Lakshmanan, visiting faculty of SWRE Division, Department of Civil Engineering, Indian Institute of Technology, Chennai, for his technical talk on sustainable water, groundwater management, climate change, and so on. Thank you, sir. I also extend my appreciation to Dr. S. Srinivasa Vittala, scientist, hydrogeology, Central Groundwater Board, Ministry of Jal Shakti, and Government of India, for his insightful presentation on groundwater status and management. Thank you, sir, very much for your presentation. I also extend my thanks to Dr. C.J. Jagadisha, former scientist, Regional Remote Sensing Center, ISRO, for his talk on space technology on water conservation and management. Thank you very much, sir. Moreover, I also would like to extend my sincere gratitude to Professor Ashok M. Raichur, Secretary, KSCST, and Professor, Department of Materials Engineering, Indian Institute of Science, for his encouragement in various activities of KSCST. So I would like to also express my deepest gratitude to our Executive Secretary, Dr. U.T. Vijay. Sir, your efforts in coordinating this panel and celebrating the Golden Jubilee through our webinar series are really greatly appreciated. Thank you very much, sir. I also thank my KSCST officials, my colleagues in KSCST, including project engineers, project associates, administrative officials, and accounts personnel for their involvement and support in making this webinar series successful. And to our target audience, the faculty and students from various universities and institutions, thank you, students and faculty members, for your enthusiastic participation. Your engagement is vital for the success of our initiatives and for overall development of our state. I thank you once again to everyone involved in making this event a success. Thank you, one and all.
Thank you, Mr. Venkatesh, for proposing vote of thanks. So once again, on behalf of Karnataka State Council for Science and Technology, Indian Institute of Science, I take this opportunity to thank one and all who have joined online across the state and across the country. And once again, heartfelt thanks to all our esteemed speakers who have given very invaluable information on surface water, groundwater, and water harvesting structures, even utilization of space technology for water resources assessment. Special thanks to all our esteemed guests, Dr. Professor Praveen Ramurthy, Dr. Professor Ilango, Dr. Srinivasa, Dr. Jagdish from RSC ISRO. And one information would like to inform all of you who have joined online. If you require any registration certificate, you can request through email to this forms through Google Documents. Definitely digital certificates will be issued. Digital participation certificate will be issued to those participants who have registered and who have joined online. So thank you once again. We will try to meet in the month of April for next technical session webinar, fourth webinar being conducted by KSCST as part of our Golden Jubilee year celebration. Thank you, one and all. Thank you. Good night.
Thank you, sir.
Thank you, Dr. Srinivas. Thank you very much. Thanks for accepting our invitation and giving very valuable information on groundwater status.
Thank you, sir.
Thank you, Dr. Jagdish. Thank you. Thank you all. Please send your queries if you have. Definitely, we'll try to address through email only by getting the reply from respective speakers. Yeah. Oh, okay. Thank you. Shall I leave? Prasanna.
Prasanna, you can recording end ಮಾಡಿ.
Yeah. Thank you. Thank you Once again, thank you one and all.
Just leave the call in for call.
Nice. ಚೆನ್ನಾಗಾಯ್ತಲ್ಲ.
ಚೆನ್ನಾಗಿದೆ ಸರ್.
ಎಲ್ಲ